All right, hey everybody, it's Mr. Cahill. I'm here to walk you through our first day of remote learning. So go ahead and hit pause anytime that you need to. And what I'm going to do is I'm going to have you get out your math notebooks, wherever you're going to be keeping your notes. And it might make it easier for you to keep track of everything if you start numbering your pages. So whichever page you are starting on, you're going to label it page number 1. Okay, so I'd put that up in the top right corner or the top left corner, whichever page you're looking at. Go ahead, put page 1, copy down probability notes, day 1. Okay, and I've obviously gone through and written a lot of this stuff out, so you might have to pause to be able to get all this down. But the idea would be at the end of this video, your note page should look similar to my note page. All right, so we want to try and get everything written down as much as you can. All right, what we're going to start with is a carnival fishing game. So we have a friend, and his name is Mike, and he's going to go to the carnival, and he wants to win a stuffed animal. And how this fishing game is going to work is that Mike pays them some money, and once he does, he gets to fish until he catches a fish. So not catching a fish is not an option. He's going to keep on fishing until he catches something. All right. Now, if he catches a green fish, he will win a stuffed animal. If he catches anything else, he will lose. All right. So, first question, what do you think is the chance that Mike will catch a red fish? You can either pause if you need to think about that for longer, or I'll give you 5 seconds and then we'll talk about it. All right, the chance of Mike catching a red fish, if this is our fish tank right here, how many red fish do we see? 0. So there is no chance of Mike catching a red fish. That would be our answer there. What percent of the time would you expect him to catch a green fish? Now he has a chance to do that. So I'll give you a chance to think about it. We're not going to go over the answer just quite yet. We're going to go down a little farther, and then we will come back to this question. Okay, first we're going to do some vocabulary and see how do we actually find a probability. So, vocab, make sure that you get this written down. A probability is a measure of the likelihood that an event will occur. It is the odds or the chances of something happening. Okay, the way that we calculate it, it's a fraction. No! We will look at the part and we will compare it to the whole. That's what all fractions do, right? Is a part compared to a whole. So the probability, the part is the number of desired outcomes. Sometimes you will see it written as the number of favorable outcomes. If you're thinking about being at the carnival and trying to win this game, it's how can you win? How many different ways are there to win the game? Out of the whole is the number of total possible outcomes. How many total things could occur? Okay. And if we find that probability, if we put the desired outcomes over the total outcomes, that's all you have to do. Sometimes we have to reduce our fractions, but that's finding probabilities. Okay. So going back to that first example, the probability of catching a green fish. How we abbreviate this probability instead of writing the word out over and over and over again is we'll write a big capital P, and then we will do parentheses. And in the parentheses, we put what we want to have happen. So the probability of a green fish. Probability of getting green is equal to, and we'll put our fraction bar. Now, in our numerator, that's how many ways are there to catch a green fish. There is 1 green fish in the tank. Out of the total number of things that could happen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The green fish is still a part of the whole. So 1 out of 10 is our probability of catching a green fish. As a fraction, it is 1/10. As a decimal, 0.1 or 0.10, and as a percentage, 10%. So that question earlier, 10% of the time we would expect him to catch a green fish. 1 out of every 10 times. What is the probability? Let's see if I can pull this back down here. What's the probability that Mike will catch a bluefish? The probability of blue is going to be equal to, it's the same fish tank, so we still have that same 10 total possible options. Now, our likelihood of catching a blue and winning, our favorable outcomes are 3. There are 3 different ways for him to win. So, as a fraction, 3/10. As a decimal, 0.3 or 0.30. And as a percentage, 30%. What would be the probability of him catching a yellow fish? Probability of a yellow is still going to be out of 10. Now there are 1, 2, 3, 4, 5, 6. We have a 6 out of 10 chance to catch a yellow fish. Now think back to when we did fractions. If it's 6 out of 10, we can reduce. And whenever we can reduce fractions, we want to. So 6 out of 10 have a common factor of 2. And we would get 3 out of 5. So as a fraction, our answer is 3/5. As a decimal, 0.6, 6/10, 0.6 or 0.60. And as a percentage, 60%. All right, we do have a couple different kinds of vocabulary, or different kinds of probability, sorry. We have theoretical probability, and we have experimental probability, okay? So theoretical, it's built into that word, it's the theory, okay? It is what we would expect to happen. It's what the math tells us should happen, right? So all these numbers that we were finding, all those probabilities up above, those were all theoretical probabilities. It's what should happen. He should catch a green fish 1 time out of 10. It doesn't mean he's guaranteed to catch a green fish once every 10 times, right? Now, his experimental probability, or any experimental probability, is what happens when you actually do the event. So when Mike actually starts to go fishing, if he plays the game 4 times and catches a green fish every time, then his probability of getting a green was 4 out of 4. Okay, it's whatever actually happens when you do the event. If you do the event enough times, if you go fishing over and over and over again, eventually your experimental will always match your theoretical probability. Okay, and that doesn't always seem like it should make sense, but we will work on that as we go through this unit so that you can see how that experimental does eventually match the theoretical probability. Okay. All right, one more question. Sometimes we'll see probabilities not of one event happening, but of a couple things happening. So here we're going to be looking at the probability of getting a fish, so still catching one fish, and that fish, you will win the game if the fish is green, or if it's blue, or if it's yellow. So now, what's our probability of getting either a green, or a blue, or a yellow? We have 10 fish still in the pond. Yellows are good, 1, 2, 3, 4, 5, 6. Blues are favorable, 1, 2, 3, or 7, 8, 9. Green is still desired, 10. There is a 10 out of 10 chance of winning the game now, if these are the rules, which would reduce to 1 or 100% if you're using a percentage instead of fraction or decimal. So, talking about probability, these are the words that we use when we talk about probability in math. Okay. First off, probability is always going to be a number between 0 and 1. You cannot have a negative probability, and you cannot have a probability that is greater than 1. If you ever get that, if the calculator ever tells you that your answer is 12, you know that you've done something wrong. Okay, so go back and double check. So this is our number line. Our number line goes from 0 all the way up to 1. Those are our high and low numbers. If something has a 0 chance of happening, a 0% chance, it is impossible. It cannot happen. On the other end, if something is 100%, it is certain. Sometimes you'll hear people say it's guaranteed. Either of those words is fine. So impossible or certain, and then in between, halfway, 50% is equally likely. When we flip a coin, heads and tails are equally likely events. They are 50%. Half the time you'll get heads, half the time you'll get tails. Anything in this range from impossible to equally likely, anything from 0 to 1/2. So if you have a probability of a fourth or an eighth or 3/8, anything that falls in this range, we're going to call it unlikely. And anything in the range from 1/2 up to 100%, or 1, if you had 3/4, or if you had 51%, that's going to be likely. It's more likely to happen than it is not. Even if it's really, really close to that 1/2, it's still likely. All right, hopefully that made sense. If you need to, you can always go back and rewatch any of those things. If you have any questions, you can send me a message, or you can wait until office hours on Monday, and I'd be happy to go over things then. Otherwise, I will see you back in class, and you will have another assignment on Friday. Friday for cohort A. I think it would be Tuesday for cohort B. So good luck, everyone. I will see you all again